Hi, and welcome to Grant Thornton's Blockchain Awareness course. In this course, you will learn the basics of the blockchain and how it will change the world in technological means. This course consists of 9 definitions, knowledge, and anchoring for supporting theory. The first activity consists of blockchain fundamentals. To understand this technology, we believe that having this chapter will give you a first touch of what blockchain is. Then, we will explain how transactions are recorded on a blockchain, what consensus is, and what is the structure of a chain of blocks. Moving forward, we will explain what smart contracts are and describe the different business landscapes. Next, you will learn the difference between public and private blockchains, as well as the comparison between the most popular. Finally, you will understand the difference between cryptocurrencies and tokens. Well, let's get started. Blockchain fundamentals. First of all, you need to understand that blockchain is a new, disrupting technology for recording transactions and tracking assets in a business network. First things first, here are some key words that you must understand about blockchain. Peer-to-peer is a network in which interconnected nodes, or peers, share and exchange information without the need of a central authority. Thus, there will be no need for intermediaries or authorities that take decisions over the other peers in the network. Wallet and keys. To maintain a secured transaction, blockchain uses public and private keys. By creating your wallet address, an application where you are going to store your tokens or digital assets, you are generating a unique public key and private key. Your public key is your public address, similar to an IBAN account, in the blockchain network that certifies that you exist. Your private key is your secret and most important code, similar to your password for, say, internet banking, that secures, encrypts, and signs your public key. Both the public and private key are used to validate and approve a transaction in blockchain. Transaction validation. Because blockchain is a peer-to-peer network, each peer validates that everything is correct and that there is no double spending. Ledger is the single source of truth. Transactions are recorded on every peer in the network, which stores the ledger and updates it in real time. And that's it. Easy peasy, right? Now let's talk about transactions. To understand the blockchain fundamental of transaction, we will use an example of how to transfer a token from Alice's wallet to Bob's wallet. For this, we will explain a transaction based on Bitcoin's blockchain. First, the transaction must contain the information of the recipient, which is Bob's anonymous ID on the web, the public key, meaning the public address. Then, the sender, Alice, must introduce the amount of the token she wants to transfer to Bob. After that, Alice signs the transaction with her private key. After the transactions are signed, it is broadcasted to all the peers in the blockchain network. Each peer in the network receives the transaction, verifies it, and validates it. After that, this transaction is appended to the ledger, and the balance of both Alice and Bob have updated accordingly. This is how a Bitcoin transaction looks. There is a lot of information, like the total amount, the size, number of confirmations, etc., but we will explain to you the most critical part. The black box in the upper left of the screen is the ID of the transaction. The blue box on the left of the screen is the Bitcoin address, the public key, of the sender. The green box on the right side of the screen is the Bitcoin address or public key of the receiver. The red box on the upper right side is the number of tokens sent in this transaction. It is important to know that to be 100% sure that the account exists and is a trustful transaction, It has to have at least 6 confirmations in the network. Let's move to the consensus explanation. First, we learned some concepts like peer-to-peer, wallets and keys, transaction validation, and ledger. Now let's learn some new concepts. Block is what makes the blockchain. It's composed of transactions and organized in chronological order. Mining, a process to validate transactions and build the block. The miners are the peers that confirm transactions and seal blocks. Consensus is a network agreement on which block goes next into the chain. Decentralized. There is no need for a single point of trust. The information is stored on the ledgers of every peer. So there are updates in real time, and everyone has a copy of the ledger. This is the Bitcoin transaction lifecycle. In this example, you will understand what consensus is and how it works. We will use an example of Rob's quest to send money to his friend Laura, an amount of 0.3 Bitcoin. Rob needs to follow the following steps. He opens his Bitcoin wallet that can be installed on any device, laptop, tablet, smartphone, etc. Then scans or copies Laura's address, her public key. After that, Rob fills in the amount and the fee that he wants to pay and sends. Now, it is time for the machine to start working. First, the wallet signs the transaction using Rob's private key. Second, the transaction is propagated and validated by the network nodes. All nodes of a blockchain network validate all transactions by validating that the Bitcoin's input of the transaction come from a previous valid transaction, that the signature of the originator is indeed linked to the Bitcoins used, and that the original balance of the originator is positive. But what does a miner do if his task is not to validate the block? They build blocks and propose them to the community consensus to be the next accepted block. To obtain this consensus, they must do a proof of work, find a hash that matches the difficulty challenge. Until now, 10 seconds had just passed. Third, miners include the transaction in the next block to be mined. Then, miners build the block and propose it to the community consensus to be the next accepted block. After that, it's mining time. It means that the miners are trying to find the hash in order to seal the whole block and to add this new block to the blockchain. Fifth, the miner who solves the proof of work propagates the new block to the network. All the nodes of a blockchain network validate a block proposed by a miner before adding it to their version of the chain. They verify that the block satisfies syntax rules, that the block is less than 1 megabyte, XBT before hard fork of November 2017, that the block hash matches what is announced in the header and corresponds to the difficulty challenge. Sixth, the nodes verify the result and propagate the block. Seventh, Laura sees the first confirmation. Finally, new confirmations appear with each new block that is created, and the process is finalized. So far, so good? Now let's talk about structure. Here, you can see that every new block is chaired by the previous one through a code, or hash. As its name says, a blockchain is composed of a chain of blocks, where sets of transactions agree grouped in blocks. Each block contains the header and the set of transactions. In the header of each block, you can see the block number, the previous block's hash, and the Merkle root. Merkle root is a type of cryptography algorithm that uses hash functions to build a very tiny footprint of the whole list of transactions stored into a block. The hash code is a deterministic cryptographic technology used to protect the blocks. making any change in the input to produce a unique output. This structure and security feature gives three benefits to the blockchain. Standardization gives a standard structure to the information, making it easy to use and organize. Fast. Transactions are validated in real time, and the querying process is executed very fast. Strong. It's impossible to hack. To hack the blockchain, you must hack every block of the chain before a new block is generated. This means in a very limited time frame, you would also need to hack at least half of the nodes in the network because all of them have the same copy of the ledger. Here are two more important features about blockchain. Irreversible. This is because the blockchain technology doesn't allow you to change any transactions made, even if they were made by mistake. Instead of that, if you are authorized, you can make a new transaction to correct the previous wrong transaction. In this case, both transactions will be visible in the ledger. Historical. This is because the blockchain saves all the transactions into blocks, so every transaction is added to the chain of blocks in chronological order. It's time for a recap. These are all the concepts that we've learned about blockchain. Do you remember them all? We mentioned smart contracts before, but we haven't explained what they are. In simple words, smart contracts are computer programs that can automatically perform some function. It is an agreement or set of rules that govern a business transaction stored in the blockchain and executed automatically as a part of a transaction. Now, a smart question. Can Bitcoin be used for other things than money transfer? No. The Bitcoin scripting language was deliberately designed with no iteration and no loops. This limits significantly the generality of Bitcoin-based applications. Can you use Bitcoin blockchain to track bonus malus for motor vehicle insurance? No. You need a different type of blockchain that can support business logic on a transaction level. Bonus malus is widely used in the EU and UK, where the payment of a claim triggers the update of the premium of the next term. Here is an example of legal rules of bonus malus for France. Reference calculation period: 12 months ending 2 months before the annual term of the contract. Exclude some types of vehicles: motorbikes and tricycles up to 125 cc's and below 11 kilowatts, firefighting and ambulance vehicles, vehicles exceeding 30 years, tractors, and agricultural vehicles. Only accidents where the insured has a part of responsibility are taken into account to calculate malus. Claims with no malus include parking accidents, thefts, fires, and broken glass. Each year without an accident involving one's own responsibility decreases the premium by 5% with a lower limit of 50%. For each accident involving one's own responsibility, the premium increases by 25% until an upper limit of 3.5. Implementing these rules with Bitcoin opcodes only is impossible. A distinct application must be developed and distributed. This application is called dApp, a computer program that is securely replicated for execution by all nodes of a blockchain network in association with a transaction. dApps, decentralized applications, are composed of a back-end and a front-end. The back-end code runs on a blockchain network, and the front-end can be anything: JavaScript, PHP, Python, etc. Smart contracts are implemented in Ethereum blockchain and are more suited for unpermissioned blockchain networks with a large number of nodes. Chain codes, a concept similar to smart contracts, are implemented in the Hyperledger Fabric blockchain, more suited for private blockchain networks with less than 20 validators nodes. First, we need to know that there are two different types of blockchain: private and public blockchain. A public blockchain technology can be used for private purposes, but its availability is based mainly on a cryptocurrency. It has four main characteristics: scalability, a large number of nodes and transactions; popularity, to attract miners to secure the chain; programmability, for flexible applications; and security, against attacks. A private blockchain is a technology that can be used only for private and corporate purposes. It has three main characteristics: confidentiality, required by regulations; performance, to support a large number of transactions; and programmability, for flexible applications. Now, let's talk about public and private blockchains. Here on the screen, you can see some examples of private and public blockchains. The private blockchains are Ripple, Hyperledger, and eGas. The public blockchains are Ethereum, Neo, Bitcoin, Litecoin, Dash, Zcash, etc. Here you can find a chart comparing the most popular blockchains and how they act on each characteristic. It's time to explain one of the best-known uses of the blockchain technology: cryptocurrencies. You didn't understand it? Well, okay, no problem. It is called crypto, from cryptography, currencies, money in actual use or circulation. A cryptocurrency is a digital or virtual currency that uses cryptography as foundations. The consensus-keeping process is secured by strong cryptography. Cryptocurrencies are digital representations of value, issued by private developers and denominated in their unit of account. Here you will find a guide to crypto tokens usage and value. Read it carefully. And it's over. It is time to say goodbye. We hope you have enjoyed your time with us learning about blockchain.